Hi everybody. So, it is another beautiful day outside. Hoping it keeps that way for Memorial Day. Today I'm going to talk about performing operations on rational expressions. So we've done simplifying them down. Now we're going to do adding, subtracting, multiplying, dividing with them. Alright, so first things first. I chose to start with multiplication and division just because I think that those are easiest. So let's first talk about rational numbers, because the idea of rational numbers is very similar to the idea of rational expressions. Okay, so multiplication. When you are multiplying, get rid of division here for a second. If you are multiplying rational numbers, so like these fractions here, you just multiply straight across. So 1 times 3 is 3, 2 times 4 is 8, and you get 3/8. Easy as pie. Alright. So when you're multiplying rational expressions, it's very, very, very similar and very, very, very much easy like that. Okay. So if you remember back to when you learned how to multiply rational expressions like this, you can take a look crosswise to see if anything can be canceled out or simplified. So looking crosswise, I actually see that I have 1x plus 1 here and 1x plus 1 there. So seeing that I have 1 on the top and 1 on the bottom, I'm going to cancel those out and those just become 1s. So what I have left is 2x plus 3 on top there, and on bottom what I have left is x plus 2. Easy peasy, that's all I have to do. Okay, division. As you know, division is so much fun. Okay. Division of rational numbers, if you recall, means that you're multiplying by the reciprocal. So if I rewrite this as multiplying by the reciprocal, it's going to be times 3 over 1. Multiplying straight across, you get 3 over 2 as your final answer. So if we take a look at our rational expression, I'm going to rewrite that as the multiplication of the reciprocal, or the flipped version of the second. 2x plus 2 times x plus 2 over x minus 3. So taking a look again crosswise, I notice there is an x plus 2 there and an x plus 2 here, so I'm going to cancel those guys out, which leaves me with 2x plus 3 on top and 2 times x minus 3 on bottom. Remembering that that 2 is not just multiplied by the x, but it's multiplied by the entire quantity, x minus 3. So if I were to go another step further and simplify, I would say that I have 2x plus 3 over 2x minus 6, distributing that 2 to both pieces of that parenthesis part. And that would be my final answer. Since I can't take anything more out, I can't cancel those 2's in front or the 2 x's because they are being added or subtracted, remember. Okay, moving on. Okay, so starting with addition. Remembering how we add rational numbers before we go on to the rational expressions part. Rational numbers, you have to have a common denominator in order for you to add those. So if I look here at my denominators, my least common denominator would be 4. So that's the lowest number that I could have that I could make out of those two numbers. Alright, so I would have to multiply this by 2 on the top and the bottom in order for that to have a 4 on the bottom, just like this one, so that we could add them. So we'd have 2 over 4 plus 3 over 4. That will give you 7/4. Now I'm not going to worry about changing that into a mixed number or a decimal or anything like that, because when you're working with rational expressions like this, it's going to be you're not going to be able to reduce it down into a decimal or a mixed number because you'll have those x's in there. Okay, so simply enough, you have two common denominators on the bottom there, which means all you have to do is add the tops. So x plus 8 plus 2x all over that x minus 4, or x plus 4. Okay, so if I go ahead and I continue moving on with this, simplifying my common terms, I get 3x plus 8 over x plus 4. Now I can't take anything out of the top or anything out of the bottom to simplify that any further, or to try and cancel out anything, so I'm done. That is my final answer. Okay, so now if we talk subtraction, subtraction of rational numbers is just like addition, except we are going to make sure that we are subtracting. Same deal though, we need the common denominator. So our least common denominator would be 6, or the multiplication of my 2 and my 3. So in order for this one to get to 6 on the bottom, I'd have to multiply by a 3. In order for that one to get 6 on the bottom, I'd have to multiply by a 2. Giving me 3/6 minus 2/6. Giving me 1/6 as my final answer. Now, subtraction of rational expressions is a little bit trickier because you have to remember to give that subtraction sign in the middle to everything, to every part. But if you find that common denominator first, it makes it a little bit easier. Okay, so we want to find the common denominator between 4x and 2x plus 1. Now, here, if you remember, the least common denominator was the multiplication of the 2. This is the same case, and in many cases, if you are not sure what the least common denominator is, you can go ahead and just multiply the 2 and make that your common denominator. So my least common denominator is going to be 4x times 2x plus 1. So I'm going to multiply that onto the top and the bottom, just like I did here. Or I'm going to multiply by what I need. Alright, so noticing that we just need a 2x plus 1 for that term, and a 4x for that term, we are going to multiply. So, x minus 5 over 4x, we're going to multiply that quantity by 2x plus 1 on the top and the bottom. Subtracted from x plus 7 over 2x plus 1, knowing that I only really need the 4x to complete that bottom denominator chunk. So, going through, doing what I have to do, I know that I'm going to have a common denominator on the bottom of 4x times 2x plus 1. And on the top, I have my x minus 5 times 2x plus 1 minus my x plus 7 times 4x. Now, remembering that that subtraction sign has to be given to each part. So first I'm going to multiply, because multiplication comes before subtraction. So, multiplying these two terms, I have 2x squared plus an x minus a 10x minus a 5 subtracted by 4x squared plus 28x. Okay. And that's all over 4x times 2x plus 1. Alright, now you know why I saved subtraction for last. So, giving that subtraction sign to both pieces, 2x squared, I'm going to combine those two to make it negative 9x minus 5 minus 4x squared minus a 28x, all over 4x times 2x plus 1. Alright, still chugging along. I'm going to combine some like terms. So I see an x squared and an x squared, and I see an x and an x. So my x squared like terms, I've got a 2x and a negative 4x squared. So that's going to be negative 2x squared. My x terms, I have a negative 9x and a negative 28, which gives me a negative 37x. And then I've got this lone constant there, minus 5. Now you notice I haven't simplified my bottom. A lot of times you'll be able to get to this point and you'll be able to factor something out so that you will be able to cancel something on the bottom with something on the top. So I haven't seen anything throughout this point to show me that. But just to check and see if I can factor this top chunk, I'm going to first take out a negative so that I can have my x squared term being positive. Now, just because I take it out doesn't mean it goes away. Because I don't have anything to divide it by, because I don't have anything on the other side of my equation, I cannot just take that negative away. Otherwise it changes the value of my expression here. It has to hang around, but I can take it out of that larger chunk on the top here. So remembering that with a 2 in front of my x squared, I get to use that magic x, 10x squared, and 37x. There is nothing that will multiply to 10x squared and add to 37x. That's a little extreme. So, knowing that, I know that this is my final answer. And then if I wanted to simplify it and get it down into a form, I could multiply this out and give my negative back to all of my terms. Alright. So, now for some more examples. Let's do this first one first. So we've got a multiplication. Alright, and we've got a couple of binomials in here. So, let's see what we can do. I notice right away that this is factorable. So I'm going to factor out what I can, just so that I can see what I can cancel crossways. Because the more I cancel crossways, the less I'll have to cancel after I get it all the way through. So 2n plus 3. 2. Oops, here. You get a 2 times 2n plus 3. Okay, I don't see anything else that is factorable. So I'm going to go ahead and I'm going to look for cancels. So right away, I see a 2 and a 28. Now if I were to cancel those, 2 and 28, I would be left with a 14 there. I also see a 5n to the third, 5n plus 1 to the third, and a 5n plus 1. Knowing that if I cancel that, this is going to become to the second, because I only took away one of those 5n plus 1s. Okay, now canceling an n, knowing that this will be just n to the first, or just n, and I see a 4 and a 12. Okay, 12 divided by 4 will just be 3. So this is what I have left here. This is what I have left there. I canceled my 4 to get my 3n here. I have a 5n plus 1 to the second, and I have a 14. I don't see anything else from top to bottom that could be canceled. So I'm going to multiply across. 3n is left there times 2n plus 3 there. A 14 and a 5n plus 1 squared. Now right away I don't see anything else that can be canceled. So this is my final answer. You can multiply it out so that you get a solid answer, but this is your final answer. This is all that can be canceled at this point. If you were to multiply things out, then they would have addition and subtraction signs in between, so you would not be able to cancel anything out. So even though 14 times 5n might be able to be canceled with 3n, it's not possible because after you distribute that, you'll have that plus in the middle that won't let you. Whoops. Okay. So, next example. Addition. Yay! And yay, they already have common denominators, so you know this is going to be a piece of cake. So I'm going to write down what's on top with that addition symbol in between. All over 25x to the third. Simplifying this a little bit further, I see an x term and an x term, and a y term and a y term. So my x terms will be x and 4x, which is a 5x. Y terms 3y and a minus 2y, which just leaves me with a positive y. All over 25x to the third. Noticing that I cannot cancel this x and this x. No. Canceling. This x is attached with a plus, which means that it cannot be canceled. Okay. Moving on, one more example. Division. Just as easy as multiplication, except you just have to flip it first. So, keeping my first term the same, multiplied by the flip of my second. Alright. Now, right away before I multiply, I want to factor things out to see if anything can cancel. So here I see that I can factor out a 7, leaving me with a 10x plus 4. Here I notice I can factor out an 11, leaving me with a 10x plus 4. This opens up a lot for cancellation. Because now I have this 10x plus 4 and this 10x plus 4. One's on top, one's on bottom. Get rid of them. Alright. Then all I have left is this 11 and this 7. Okay, now I want to take a look and see what else I can cancel. I notice there's an 8 here and an 8 here. They're separated with multiplication only, so I'm going to get rid of those. So, this leaves me with this 11 here and this x here. And it also leaves me with a 7 on bottom. So all of this mess reduces down to a simple 11x divided by 7. So, you can start your homework. If you have any questions, let me know. Remember to flip division. Remember to get a common denominator with addition and subtraction. Other than that, good luck, and ask me for a paper copy if you need one. Okay, bye-bye.